Good morning, scholars. Today we will be working on Elementary ELA, Grade 3, Unit 4, Forces and Magnetism, Distance Learning Packet, Week 4, Day 3. So, yesterday, or previously, we worked on finding introduction to the unit, the content, vocabulary. We did our first read and we responded to the text. So let's go over and review some of the things that we did yesterday and Monday. So on Monday, we watched a video about Moby and we talked about magnets. So can you guys describe what you see in this picture? Yeah, the magnet is attracting items that are made out of metal. Based on what you see in the picture, what do you think is happening? Did you say that the North Pole and South Pole of the magnet are creating a magnetic field that is attracting objects made out of metal? If you did, you're absolutely correct. Why do you think the pencil is on the floor? Yeah, the pencil isn't made out of metal. Neither is the rubber band or the penny. So the magnet is not able to pull the rubber band or the pencil or the penny because they are not made out of the same metal that the screws and nails are. In this unit, you will read about how different forces make an impact on our lives. These forces can make a difference in our lives by improving the way we do things. We're going to discuss magnetism and electricity. So, you guys should have already done this, but let's review. Did you stop and jot? What do you already know about magnets? What do you know about electricity? And how do you use them in your everyday life? Go ahead and share out. Wonderful. Alright, so we reviewed 4 new vocabulary words. This should have been completed on Monday. Read the word and its definition, examine the picture, write a synonym, explain your understanding of the word, and use the word in a sentence. We also learned about the word force, attract, repel. Please be sure to send me pictures of your completed assignment. And then yesterday, on your own, you guys were supposed to complete this section. We read pages 4 through 8 of The Attractive Truth About Magnetism as a class on Monday, and I encourage you guys to reread it and to answer these text-based questions. Magnetism is a word used throughout the text. What is magnetism? Go ahead and share. What does the author mean when she states magnetism is an invisible force? Can you use evidence from the text to support your answer? Yeah. We're going to talk about this a little bit more later. What are the characteristics of a magnetic field? Use evidence from the text to support your answer. Make sure that you're referring to your text on the side to help you answer in complete sentences on this side. And here's your definition bank to remind you of important words you should be using when answering your questions. We read this text together. You guys have the text in front of you, and I have the YouTube clip of me reading it to you if you need it reread to you. So I'm not going to read it again right now, but I want you guys to refresh your memory. I'll give you guys a moment in a minute, but now we're on to day 3. This is our activity for today. Today we will reread and annotate pages 4 through 8 of The Attractive Truth About Magnetism in order to gain evidence and information that will support you in answering the questions. So I want you guys to take a moment now and reread pages 4 through 8, The Attractive Truth About Magnetism. As you guys read, I want you to annotate. Alright, go ahead. Alright, welcome back. I hope that you were able to reread 4 through 8, The Attractive Truth About Magnetism, and use the annotation key. Now that we've done step 1, let's look at step 2. Using your annotations, answer the questions below with complete sentences and appropriate grammar and punctuation. Use evidence from the text to support your answers. Are you ready to try? Alright, so let's look at our first example. You have the power to push or pull objects without touching them. Your superpower even works through walls or water. All you need is courage and a really strong magnet. Okay, so you don't really have a superpower, but you do have these super cool magnets that can do these things. Magnets use a force called magnetism. This invisible force allows magnets to attract or repel objects, just like a superhero. Magnets are all around. They're in your TV and computer. You probably have one on the refrigerator to hold up your latest art project. Great, now that we've reread this text, let's look at our text-dependent question. What does the author mean when she states magnetism is an invisible force? I see this key word here, magnetism. Let me see if I can see where they talk about magnetism or magnets. And it being invisible, an invisible force. You see these quotation marks? This tells me that this is from a specific sentence in the text. I want to find the sentence because this is going to give me a clue to what I should be writing about. Oh! Magnets use a force called magnetism. This invisible force allows magnets to attract or repel objects just like a superhero. They do say invisible force. So this might be the closest sentence to this one. Magnetism is an invisible force. This invisible force. So this invisible force is called magnetism. So what does the author mean when she states magnetism is invisible force? Let me rewrite it using the sentence. When the author says that magnetism is an invisible force, comma, she is saying that magnets can attract or repel objects the ability to attract or repel can not be seen with your eye. It is invisible. I used evidence from the text, and I used evidence from the text to help me understand how to answer this question. Alright, let's go on to the next one. How does a magnetic force flow through a magnetic field? Use details from page 6 and page 7 to support your response. Luckily, we have our options right here in front of us. When you put two magnets near each other, you can feel a push or pull. The movement you feel is caused by a magnetic field. No, they said magnetic force flow. That's the phrase that I'm looking for. Magnetic force flow. A magnetic field is an invisible area around an object. Oh, that's what it's called. This field exerts, exert means to push, a magnetic force that attracts or repels other objects. So the magnetic field is how the force flows through the field. It attracts or repels objects. The magnetic field looks like curved lines around an object. Metal objects are most sensitive to magnetic fields. Any metal object that comes into a magnetic field will be attracted to or repelled by the magnet. Magnetic fields are everywhere. In fact, even Earth acts as a strong magnet. Deep in the Earth's core, magnetism is created. The inner core is made of solid iron, the outer core is made of iron and nickel, and the liquid iron moves around the solid iron. It creates an electric current. This electric current causes a magnetic field to form around the planet. So Earth is one giant magnet. Whoa. Every time I read that, I get excited. Let's go back and look. How does magnetic force flow through a magnetic field? I'm going to start by using the sentence. Magnetic force flows through a magnetic field. What would you guys write next? Those are some interesting ideas. Yeah, the magnetic force flows through a magnetic field without being seen. That's true. You can't see it. Magnetic, I'm going to quote from the text. In the text, it says, the magnetic fields look like curved lines around an object. Metal is most sensitive to magnetic fields. The field attracts and repels objects. All right, I think that that's enough. We answered the question, how does the magnetic force flow through a magnetic field? The magnetic force flows through a magnetic field without being seen. And the text says magnetic fields look like curved lines around an object. Metal is most sensitive to magnetic fields, and the field attracts and repels objects. All right, are you guys ready to do one on your own? I hope so. All right, this one you guys are going to do by yourself, and then you're going to send me a picture to show me that you completed it. Every magnet has two parts, a north pole and a south pole. These poles are at opposite ends of a magnet. It's these different opposite parts that determine if magnets attract or repel. Bring the north pole of a magnet toward the south pole of another magnet. The two will pull together almost immediately. But if you bring their north poles together, they will push apart. This crazy push and pull is called magnetic force. Will one south magnetic pole and another south magnetic pole ever be attracted to each other? Please use evidence from the text to support your answer. Why don't you guys go ahead and orally tell me, what do you think? Will a south pole and a south pole, will they be attracted to each other? Why or why not? Yeah, you're so smart. Exactly. They wouldn't be, because it says in the text that when you have two north poles together, they'll push apart. So two south poles would have the same reaction because they're the same. Opposites attract. Do you remember that from the text? Opposite poles attract. North is attracted to south. South and south, never together. North and north, never together. So now that we have our evidence, let's go ahead and write it down. Remember these 4 steps to answering text-based questions. Read the question, reread the section of the text, underline evidence that helps answer the question. Can you read the last one? Yeah, we followed all of these steps. Did we read the question? Did we reread the section of text before we answered? Did we underline evidence that helped understand the question? And did we write out our answers? Excellent. So I hope you're ready now to try this on your own. If you have any questions, let me know. I will see you guys tomorrow for day 4. Okay, bye.